Viewers, I decided to do some time switch repairs here. I got my analog Warburton Franki, which is actually made by part of Warburton Franki that is called ANI. I just noticed that now. Interesting. They must have had another trade name, this Warburton Franki. I just replaced the front half on that one. Off that other digital time switch there. That one there's all nice and new. I put this little with all the, that's where the screws go for that wheel. Sits in slots in there. That's why all these cases have got these windows and a little clip thing on there. The spring washers are back on there to hold that nameplate on. That's fixed. Good as new. And this other new one, in the process of switching the back halves over. So the back half of this one is going to be its replacement for this switch. And I'll pull all these terminal bolts out, because these are all old and stripped, and put all the new terminal bolts in. That was made in 2012. And there's all the good insides here, good quality stuff. A Lear line capacitor, 4700 microfarad, 35 volt, 105 degrees Celsius rated electrolytic. That's the main filter capacitor for the relay, so it's a DC relay. But 2 horsepower, 250 volt AC relay, I think it is. Yep, Australian, by Mel's Rubber Innovations. Australian made wiring. Although it is always going to be right here, switch mode, it's got to be hooked up correctly, so active on the outside, then neutral on the inside. MOV, high quality stuff, a lot of surface mount devices on this. WF time switch, Warburton Franki Energy Controls. Super capacitor, backup memory, some surface mount components on there. There we are. It's exactly the same but a newer model. And WF's latest logo too, Warburton Franki. Look at that inside another one of these once again. WF 1730. Warburton Franki Energy Controls. WF 17/30 time switch. 3 revision C, issue 3, part number 14921. As you can see, there isn't any surface mount on here. This pretty much resembles a J-car kit actually. The same quality circuit boards and everything. You can virtually build these things from a kit. So easy and so high quality. You got the main relay, filter capacitor, noise suppression, neutral and active going into there, some dropping resistors and MOV, filter capacitor, high Tane brand, 1000 microfarad, 35 volts, rectifier diodes, and that chip there, which is I can't see, but I think that's what keeps time, not quartz based, there's no quartz on this thing. (7663S CPAZ VA949A2PR. That's a timekeeper, that one. Couple of Zenas. Yeah, pretty much the same kind of components you buy a J-car, but I think there's a little bit higher quality. Back of the screen there, 1.5 volt DC. I clipped that screen out, have a good look at that, because that can plug in as a separate component. Let's have a look at the back of that screen. Oh, hit my fingers. Boy, was that tight fitting getting that out. Very close tolerance in the plastic. It's a Febin brand. And that's the screen itself with the buttons on it. That just clips back in there. You can even make that DIN rail mount on a switchboard if you really wanted to. Yeah, how cool is that? Or even modify that so it talks to a VFD, connect it to one of these and stick it on a switchboard and have your speed control settings on the screen. That would be a good idea. Modify one of those to talk to one of these and stick that in the outside of a control box and have your speed, forward, reverse, high and low speed, stop, and another spare function there. Have your RPM and your frequency displays on the screen. That would be cool. How useful is that? Anyway, it's got this nice big relay here. It's a 30 amp relay for the switching. Tekamisawa. Japanese brand but made in China. Not Japanese made. That's when they started skimping. Because the corporate tax rate in Japan, that's why they're not making them there anymore. Very good quality cabling. That is some decent cable. You don't get cable quite that good in consumer grade electronics now. 0.5mm squared, 180 degrees Celsius, 500 volt cable. 200 degrees Celsius rated cable. NEC token super capacitor, 5.5 volt, 1 farad. DC relay. I sold one of these time switches to Hamish, Australian stick, and he modified it for DC. So the relay's DC. To run one of these off DC, you just put your, I think you put your battery power here on the power supply side of the diodes. So you got a little rectifier there as well. Well, that could be it. It's got 2 pins on. No, it's got 4 pins. Yeah, it's a bridge rectifier. That. It's a little bridge rectifier. So you go on the DC side of that bridge rectifier, connect the battery to that, and you can make this a DC operated time switch off a battery. I haven't measured the voltage. I think it's around 12 volts. I think it runs off. Since this one is so broken up, it's a parts in it, I might as well just patch it up and get the summer's heat and convert it to a DC operated time switch. Good for a solar project or something. Be good for that. These time switches are still ticking along quite nicely. And they are pretty damn accurate. Ticking away happily. Okay, that's my parts unit. And now it's all done. That can be probably a conversion project, I reckon. I'll convert it at 12 volts. Probably do a video of it just to show how it was done. I'm not sure what I'll use a 12 volt time switch for, but I'll think of something. I'll do a demo of that when I'm done. See what's different on this one. Well, I don't think much. Just got a bigger resolution screen. I think it would have. And I'll test this meter next. This is another Schlumberger's readout meter, which has slightly different font number wheels in it. Does not have a hidden digit behind that black grey plastic there. It's a 3-phase, 32.2 amps per kilowatt hour, 30 to 125 amps. It's quite a big one. 4-wire, 50 Hz to 40 volt, direct wide. Anyway, that'd be next. Let's say 1996. This one, 1996 it was made. That'll be next to my meter test. Thanks for watching.